Okay, so Jai Hind, my name is Vivek Agarwal. I am the Assistant Professor in the Department of Computer Science and Engineering in AKGEC Engineering College. So today I am going to deliver a lecture on the machine learning, and today we are going to cover several topics, the initial topics or the basics topics for the subject. So I'll try to cover out the basic introduction of the machine learning and how we can differ the machine learning from the deep learning, because many of times we got confused between the machine learning and the deep learning things. So today we are trying to clarify the things, the differences. ML working system, how the ML models or the ML system works actually, the learning system, how it is going to be happen and how we can utilize that learning in our other things, in our solutions. And next we are going to discuss the type of the learnings, type of the machine learning. There are several type of the learning, so we are going to deep dive in that. And out of them, classification and the regression is quite very popular learning types in the machine learning, so we are going to have a review on these two types of learning as well. So starting with the machine learning, so as the name suggests, machine learning is the part of the artificial intelligence. Already in last few decades, the artificial intelligence has been evolved and it is now an integral part of the human life. So you can feel the artificial intelligence all around of yourself. Uh, you can use it in your mobiles, you can use it in your computers, you can see the examples of artificial intelligence everywhere. Like if you are going to on the railway station, airports, everything, most of the places are now using the facilities of the artificial intelligence. And the main, I must say, the main example you can feel of the artificial intelligence in your e-commerce things. Just see the experience of e-commerce before 10 years and nowadays, what are the facilities you are utilizing of the artificial intelligence in e-commerce things. Like you can choose the product, you can search out the product just with your voice navigation as well. You don't need to write the type the keywords in the search bar. You just need to speak out through the voice command. You can search the things, as well as initially you will have to be very careful about the keywords what are you are typing. But now if you are typing in any language or in English type things, the model or the system, the e-commerce platforms are quite very capable, enabled with the artificial intelligence to judge actually what are you are going to search. So machine learning is an integral part of the artificial intelligence. Through the machine learning things, that model, the artificial intelligence models learns how to do the things like very humans. As a human, they are born with a very less amount of learnings, but but in the prolonged journey of the life, they are going to learn many things. Likewise, we can make the machines learn and we can utilize their intelligence, their knowledge system for solving our complex problems. And if we talk about the deep learning, that is a subset of the machine learning as well. Sometimes we got confused, like machine learning and the deep learning are the two different aspects of the artificial intelligence. No, the deep learning is the more specialized, or I must say the most specialized phase of the machine learning. There used to be some limitation for the complex problem in the machine learning, which can be solved using the deep learning things. So this is the diagram. You can see the things. So next, so we can compare two things. Okay, we can differentiate the traditional programming and the machine learning using this diagram. So traditionally, what we do generally, we use the computers and provide some data and some programs, and we are expecting some output. But in the case of machine learning, we are doing a different approach. We are utilizing already the data we are having with us. So if we do talk about the learning, then we already have some event which already has been occurred, and the outcomes of these events already we are having with them. So already we are having some data, the old data, some previous or experience data, and the outcomes of these events, the outcome of these data. So we need to figure out a program which can make a relationship between that, the data and the expected outcome. So how this outcome is being influenced on the basis of the type of event or the type of the data. So after recognizing these patterns, after recognizing these the dependencies, we need to figure out them and make a program which can be utilized to solve the future problems, or the future decisions can be done using this intelligence. So ultimately, using the machine learning, use of the machine learning is to just develop an intelligence in the machine, just to which utilize in solving the future problems or the future predictions. The major application of the AI, or especially the ML, could be the medical, could be the research things, could be some pharmaceutical things. So everywhere you can utilize that knowledge set. The same thing can be shown as the conventional programming is based on the program and the data, and you are expecting some result. But in machine learning, we are providing the already happened result and the data to which was utilized for getting these outcomes, and preparing a program which can be developed using identifying the patterns or the relationship among the provided data and the outcomes already we had got from the data. So coming further, if we are going to start with working with the machine learning things, then it is most suitable if we are having a training data set of a small size. Now, if we talk about the data set, already in the previous slide, we were talking about the data. So if that data collectively, a set of data which is comprising various things, it could be textual data, it could be the images, it could be any tabular format. Generally, if we do talk about the basics, in the basics machine learning, we generally use the tabular data. So that is training data set. Training means the old experience data which is going to be work as a training data for your machine learning program, the program which we are interested to be figured out. So training data set must be the small size if we are going to prefer the machine learning. If the data set size is not small, or I must say that it is very big data set of having the multi crores entries, then might be the machine learning can suffer with various things. There could be some issues, we need to figure out them in the future lectures. So then we can go with the deep learning things. So choose your own features. Yes, this is the another things. Whenever you are providing the data, this data must be the having pre-configured data. So we must be having the knowledge of that data, actually what data we are going to supply. Can we figure out that data, or we can categorize that data into multiple sub data sets, or I must say that we can explain that data using some features, or we can using some labels. So that information, if that is presented with us, then the best choice is machine learning. But when we are don't having the good idea about the data set, like if we are having the crores of images, we don't have a good idea what kind of the set of images are they, then we can choose the deep learning in spite of the machine learning. So this is for that. The classifier available, yes, there are various kind of the classifiers available in the machine learning. In case of machine learning, we have a good variety of the classifiers, but in deep learning, that is very limited. Training time is very short. Your program can be executed, or I must say that you can process your data because the size is small and the few things are already pre-configured. So you can make the program as the initial slide we were talking about. We are having that data and the expected result already we have. Then we need to design a program. So in this case, machine learning, that training time for designing a program is quite short. But if we compare it with the deep learning, the training data set must be the large. For the deep learning application, it must be the large. There is no choice of the features because the deep learning models select the features on their own. Number of classifiers are comparatively low than the machine learning things, and the training time is quite very long because it do a very complex calculation, and it's the way to find out the features to the relationship between the feature, the relationship between the provided input and the expected outcome is quite very complex. So it took good amount of time. So ultimately we can say for the deep learning, we need a high performance computation as well. We need a good amount of resources for making some deep learning things. As well as the data must be of very good amount of size. So data must be generally, we do the deep learning things on the big data. We can understand it like if we are having a good hardware and the lots amount of data, then if it is yes, then go for the deep learning. If it is not with you, then go for the machine learning. So this is a simple diagram showing when to choose the machine learning things and when to choose the deep learning things. So now come to the how the machine learning model works. So as we started with the data already, we need to figure out a program. But for that we need to provide some input data. So we are talking about the data collection. If we need to make a program, or we need to predict some scenarios or some problems, then that must be very specific what you are going to do with your model or with your program outcome. So for that task oriented, we need to collect the data. That must be the task oriented. If the data or the experience data is not task relevant, then your model is not going to make a good predictions or good outcomes. So it is quite very important to make this data collection very task oriented. Then the provided data may not be have in the position like which can be supplied directly for the later learning type. So we can make some pre-processing things. We need to tune that data, we need to refine that data. If there is any impurity, we need to figure out that, we need to correct that impurities. If that is if some areas are the blank in the data set, then we need to make them fill as well. Some blank areas could be there, some null values could be there, some outliers may be there. So we need to correct them in this phase, data pre-processing thing. Then this is the main training part or the learning part, where what we are doing, we are applying some pre-designed classifiers or the predefined machine learning algorithms we are applying to this data for identifying the patterns or identifying the relationship between the data and the outcomes. So after that training, we are evaluating our model. After the evaluation, we are getting a learned model. Now we are evaluating that model. There are several tricks to evaluate that model. So after evaluation, if the performance is satisfactory, then we can go directly to the next phase for the deployment that program into an application which could be utilized by the users. If it is not performing well, if the performance is not so much good as it should be, then we can tune or we can make the tuning in your learning system. There are several parameters which can be tuned, which can be changed, which can be altered to make this evaluation or this performance make some better things. So this is the hyper tuning of the parameters. These are the parameters provided when we are applying these algorithms in the form of functions. There used to be several attribute or several parameters which can have some default values. We can change them as per my uses. And after this processing, this task of tuning them, just changing their value, is called as the hyperparameter tuning, and these parameters are called as the hyperparameter. So after that, again we are training the model, our learning model on the same algorithm. Then again we are getting the evaluation. If that evaluation is now satisfactory, we can keep that model and go for the deployment. Still, if the results are not satisfactory, we can go with any other algorithm, because there are several algorithms or several classifiers available in the machine learning for making the learning things for a single problem. So we can choose any other and we can try in the same way again and again. So this is a cyclic process. You can repeat it again and again until you are not happy with your performance. The expected outcome, the expected performance is not meeting out. You can keep it repeating again and again. When you are having a satisfactory performance report, you can go for the deployment. A program can be executed, can be deployed, which can be directly used in an application for the users. So this is the model how the machine learning works actually. Now if we talk about the types of the learning, we can distinguish into three main category of this learning. It could be the supervised, it could be the unsupervised, and it could be the reinforcement. Further, the supervised can be categorized into classification and the regression. ठीक है, तो मैं इसको ऐसे ही छोड़ जाऊं सब यहाँ पे. So in the case of supervised learning, we can further categorize into classification and the regression. And unsupervised learning is classified as clustering, association, density reduction, and the reinforcement learning. Let's deep dive in the things using another slide. So this is very interesting thing to understand these three different type of the learning. So First we will talk about the supervised learning. So supervised, as the name suggests, it is kind of the supervised, which a learning, kind of the learning which is being happened under the supervision of any guide. So in our machine learning, who is the guide? Actually the data is the guide, or I can say the data we are providing, for the experience data we are providing for the learning things, that is quite supervised, means that data is labeled. Like if we are providing several images as an input, as an data, experience data for my model, then every image is labeled like this is the image of element, this is the image of a black elephant, this is the image of white element, this is elephant, this is the image of lion, this is the image of yellow lion, this is the image of black lion, and this is the image of dog, this is the image of cat. So everything is supervised, means the data is quite labeled. We have the clear cut information about the data. So the model is quite having some pre information about the data. So for making some classification or making the relationship among the features or the among the data and the outcome is quite easy, because many of things are pre identified already. So kind of the learning is called as the supervised learning. And unsupervised learning, when the images, suppose there are several images, thousands of images are provided to your model for learning things, but these images are not having any label information or any kind of associated information is there, they are just raw images. Then the model will have to identify them on the basis of their feature, like the model can segregate them on the basis of their color, the model can segregate these images on the basis of their shapes, on the basis of their size, on the basis of their the intensity, the size of the image, etc, etc. So the model will have to identify several features on which basis it can make some clusters or make some some groups, or make them differentiate them. So in this case, these things are done. Like here are three kind of the data points are reflected. The green one is representing one kind of the data, one kind of the images or one kind of the data. Blue dots are representing another kind of the data, and the orange dots are representing another kind of data. So this differentiation is created by the machine itself by identifying them on the basis of some feature. It could be, as I said previously, the feature could be maybe anything. It may be the size, it may be the shape, it may be the color, etc, etc. But in supervised, everything is classified, or I must say the labeled. So you just need to use that information, and on that information you need to make some classes or make them distinguishable to each other. So kind of the learning is called supervised learning. Like here, the kind of the similar object are classified into a single class, and another type of the objects are classified into another class. So this supervised learning take less amount of time as compared to the unsupervised learning, because many of the features identification are already there, but here the model will have to identify on their own. This is very special kind of the third kind of the machine learning, reinforcement learning. In reinforcement learning, sometimes we call it like a self-learning model, like the humans do. Humans do generally in their life, as how they are. The basic fundamental of this type of algorithm is reward points. We can understood in a simple language, like in reinforcement learning, we just prepared a model and live in the environment. Now that model will do on its own activity on its own. It will decide on its own like what I should do, and will check the outcome. If that outcome is positive for the application, then some positive rewards could be provided to the system, means the learning is good. But if any action taken by the model and that is not good for your application, then kind of the activity should be considered as the negative activity, and the negative reward point should be appointed or to be assigned to the model. So that ultimately the task of this reinforcement learning is to gather as maximum as positive reward points. So if we figure out the main application areas, supervised learning is mainly used for the predictive task, like prediction of the diseases, the prediction of the share market, the prediction of the weather, etc., etc. So supervised learning is suitable kind of the predictive task. And unsupervised learning is good or widely chosen for the discovering hidden patterns. Like if you provided a set of data and you are not having any idea what data is all about, then you can apply any unsupervised learning to that data, and we'll try to find out the hidden patterns, how we can relate that data, or what are the pattern can be extracted from that data. In social media images, the kind of the learning generally we used. And the third is reinforcement learning. The main application is the real-time decision making. Like nowadays, it's very popular self-driving cars. So they are based on the reinforcement learning. Coming further. So the things already I had discussed is summarized again in a form. So supervised learning, if we talk about, can be further classified into two things, can be categorized into two different kind of learning, that is classification and the regression. I'll come to it. But unsupervised learning is when the target variable is not available, means we are not having the, as I said, it is for finding the hidden patterns of the given data. So many of times we are not having the outcome of the provided data. So for that we do use the clustering things and the association things. These are the two techniques generally already we had studied in the data science things as well. So these are the commonly used algorithm. K-means clustering, classification, and the association rules are used for these two type of methods for the unsupervised learning. And there is a special class of the semi-supervised learning when your data is having the both properties, the properties of the supervised learning as well having some properties of the unsupervised learning. So in that case also we use two type of learning. We can classify them or we can categorize them, that clustering and the classification. Already it is clustering is from here and the classification from here. So semi-supervised, when your data is having some labeled data and some unlabeled data, the outcome is, some outcome is presented there and few outcomes are not presented there. Then the combination, the property of both models then can be called as the semi-supervised learning. For that, generally we use the linear regression and the logistic regression things. Now come to the very commonly used and the very popular things. These are the classification problems and the regression problem. Both are come under the predictive modeling or the predictive learning, where we need to apply the learned model for some prediction or the decision making. So in the case of classification, we are having predetermined classes, and in the case of regression we need to figure out some continuous data. We'll discuss in the next slide, but for now, for these purposes, for the classification and the regression, we are having these popular algorithms available with us. As we were talking about the classifiers, these are the available classifiers: KNN, name based, decision tree, linear regression, support vector machines, neural network, classification and regression trees, gradient boosted regression tree, perceptron backpropagation, random forest, etc., etc. These are the only few, but we are having the a more vast list of the algorithms available for these purposes. So already we had gone through the supervised learning when your data set is labeled. This is the main point which can summarize the supervised learning. Yes. So we are having the both input features. Another main important factor is we are having the both input features, like labeled input features as well as corresponding the outputs. In case of supervised learning, both are presented here. Proper input features and the expected outcomes are properly available there. So what the model need to do, just while the learning, make to identify some relationship, or I must say the patterns, how that input features are making these outcomes, or simply we can say we need to figure out a function. We need to figure out a function that is based on values x to map the outcome y. These x are representing input features and y is representing outcome. So in the case of supervised machine learning, we need to figure out a function fxy, where we need to figure out the possible outcomes from provided input. Firstly, we are going to discuss the classification. Classification is very simple to understand. The whole data set is given. There are few features is given. For example, one feature is giving as the color of hair. Another feature is given as the length of the hairs. Another um, uh, feature is given as the height. Another feature is given as weight, and another feature is given as like the shape of the body. And on that basis, we are having an outcome feature, which is telling is the given description of any human as of any male or any female. So ultimately, the classes, there are the two classes: class A representing for male and class B is representing for female, right? So if the characteristics or the provided input string is having the outcome as men, then these data points are represented here in class A. If the data points in provided data set which is characterized or classified in the outcome column as the female, these are represented here using the triangle. We can call it class A or class B. So classification, when we are having the predefined classes, we need to categorize, we need to journalize the data into these classes. So from learning from this data set where already the input features are mapped with a predefined class, we need to make a model which is based on identifying the patterns, the relationship between these input feature values and the expected outcome. Then on that basis, we need to figure out, we need to predict the any new query which is provided to the program after we are getting from the learning things. So this is the classification problem. It could be of several types. It could be a binary classification or it could be a multi-class classification. In binary classification, the expected outcome classes would be only two. For example, the outcome classes could be the yes or no. Outcome classes could be the male or female, spam or not spam, cat or dog. Means the possible outcome classes would be always two only. So kind of the classification is called binary classification. But when the outcome classes are more than two, for example, if we are going to predict or we are having a data of temperature like the weather forecasting data, then in that case, the outcome classes could be the high temperature, the low temperature or the medium temperature, or maybe some other classes as well also. So if we are having more than two outcome classes, kind of the classifiers is called multi-class classification or multi-class classifiers. If we talk about the regression, as we see in the case of classification, the classes were predefined, but in case of regression, no classes are predefined. We need to figure out a continuous value. For example, if I am having a data set of weather forecasting, which is telling me the expected outcome or the which is containing the outcomes or the data related to the weather in terms of degree centigrade or degree Fahrenheit, like the outcome of the weather, the temperature of particular date is this, at particular time is this, like 32 degrees centigrade, and next day the temperature was 35 degrees centigrade, next day the temperature was 33 degrees centigrade, next day the temperature was 31 degrees centigrade. And there are some provided input features which are telling like the wind, the speed of the wind, the direction of the wind, or we can say the type of the sky, the nature of the humidity, the level of the humidity. These are the input factors. On that basis, we are having a outcome feature, that is the temperature. So from learning that data set, we need to predict what could be the expected temperature of coming day, of any particular day, on the basis of the input feature provided by a query example. Could be like the sky is clear, the wind is high and the humidity levels are low, then what could be the expected outcome. So in that case, we need to figure out a value, a continuous value, rather than any class. We need to figure out a value kind. So this is called as the regression. Already we had discussed there could be the two type of the variables or two kind of the features if there is any table. In next lecture, we will discuss more about these things. So if the data is tabular, then there could be various input features with the columns which are representing various input feature values, and a column which is telling about the expected outcomes or the outcomes in the previous history data. So these can be called as the independent features, and this is the dependent feature on these features. So this is here dependent variables, sometimes called the dependent variables or dependent parameters, and independent variables or independent parameters. So for today, we are keeping the things at this moment only, at this point only. So next class, we will discuss the next topic related to the things. Thank you.